Download this code from codegive.com, link in the description below. OK, let's dive deep into the dreaded world of infinite loops, how to recognize them, avoid them, and what to do if you find yourself trapped in one. We'll cover various causes, debugging techniques, and code examples across a few common programming languages. What is an infinite loop? An infinite loop, sometimes called an endless loop, is a sequence of instructions in a computer program that continues to execute indefinitely because there's no condition that will cause it to terminate. In other words, the loop's termination condition is never met. This can lead to your program becoming unresponsive, consuming excessive CPU resources, and potentially crashing your system. Why are infinite loops bad? Resource consumption. An infinite loop will constantly use CPU cycles. This slows down your computer, makes other applications less responsive, and can drain the battery on laptops or mobile devices. Program hangs. The program gets stuck in the loop, preventing it from performing any other tasks. This makes the program unusable. System instability. In extreme cases, an uncontrolled infinite loop can overwhelm system resources, memory, CPU, leading to system crashes or the blue screen of death, BSOD. Difficult to debug. Infinite loops can be tricky to identify, especially in large and complex programs. Finding the precise location of the loop requires careful analysis. Common causes of infinite loops. 1. Incorrect loop condition. This is the most frequent culprit. The condition that is supposed to stop the loop from running is either never satisfied or is always true. Example, Python. In this case, I always remains 0, so I10 is always true, and the loop never ends. Example, JavaScript. 2 logical errors in the loop body. The loop condition appears correct, but errors in the code inside the loop prevent it from ever reaching the termination condition. Example, C++. The intended behavior was to increase I to 10, but the decrement operator causes it to go in the opposite direction, leading to an infinite loop. 3. Floating point precision issues. When dealing with floating point numbers, comparisons for exact equality can be problematic due to the way floating point numbers are represented in computers. Example, Java. Because of how floating point numbers are stored, adding 0.110 times might result in a value very close to 1.0, but not exactly equal to it. Therefore the loop might continue beyond your expectation. 4. Incorrect input handling. If a loop's termination depends on user input, failing to handle invalid or unexpected input can cause it to run forever. Example, Python. If the user types something other than quit, the break statement is never executed, and the loop continues indefinitely. Error handling, example checking if the input is valid, can prevent this. 5. Concurrency issues, threads, processes. In multi-threaded or multi-process environments, shared resources and synchronization mechanisms can lead to infinite loops if not managed correctly. This is a more advanced topic, but common causes include deadlocks or live locks. How to identify infinite loops? Program hangs / unresponsiveness. The most obvious symptom is that your program stops responding to user input and appears frozen. High CPU usage. Check your system's resource monitor, task manager on Windows, activity monitor on Mac OS, top or HOP on Linux/Unix, to see if your program is consuming a disproportionate amount of CPU time. Endless output. If the loop is printing to the console, you'll see a continuous stream of output without any apparent end. Debuggers. Asterisk set breakpoints. Asterisk use a debugger, like GDB, Visual Studio Debugger, or IDE integrated debuggers, to set breakpoints inside the loop and examine the values of variables. Step through the code line by line to understand the flow of execution. Asterisk watch variables. Asterisk monitor the values of variables that are relevant to the loop's termination condition. See if they are changing as expected. Asterisk call stack. Asterisk inspect the call stack to see the sequence of function calls that led to the current point in the program. This can help you identify where the loop is originating. Asterisk logging / tracing. Asterisk add print statements, or use a logging library, inside the loop to trace the values of variables and the path of execution. This can help pinpoint the exact location of the infinite loop. How to avoid infinite loops. 1. Carefully define loop conditions. Asterisk double check that your loop condition is correct. Make sure it will eventually become false or whatever condition is required to terminate the loop. Asterisk consider using simpler conditions if possible to reduce the chances of errors. To ensure progress towards termination. Asterisk inside the loop, make sure there's a clear path of execution that will eventually satisfy the termination condition. Asterisk if a loop depends on user input, validate the input to prevent unexpected behavior. 3. Use loop counters and limits. Asterisk for loops with a known number of iterations, use a for loop with a counter. Asterisk for while loops, consider adding a safety counter as a fallback. 4. Test your code thoroughly. Asterisk write unit tests that specifically target the loop conditions and boundary cases. Asterisk run your code with a variety of inputs, including edge cases and invalid inputs. Asterisk use a debugger to step through the code and verify that it behaves as expected. 5. Consider code reviews. Asterisk have someone else review your code to catch potential errors, including infinite loops. A fresh pair of eyes can often spot issues that you might miss. 6. Use static analysis tools. Asterisk static analysis tools, like linters or code analyzers, can automatically detect potential errors in your code, including possible infinite loops. What to do when you're stuck in an infinite loop. 1. Interrupt the program. Asterisk Control+C, on most systems this usually sends an interrupt signal that will terminate the running program. Try this first. Kill the process. If Control+C doesn't work, use your operating system's task manager, Windows, or the kill command, Linux/Mac OS, to terminate the program's process. Find the process ID, PID, associated with the program and use kill PID. Restart the IDE/editor. Sometimes, the IDE itself might become unresponsive. In that case, you may need to force quit the IDE. Reboot, last resort. If all else fails, you might have to reboot your computer. However, this should be a last resort, as it can potentially lead to data loss. 2. Analyze the code. Carefully examine the loop condition and the code inside the loop to identify the cause of the infinite loop. Use a debugger to step through the code and inspect the values of relevant variables. Add print statements or logging to trace the execution path. 3. Fix the error. Correct the loop condition or the code inside the loop so that the termination condition will eventually be met. Consider adding error handling to deal with unexpected inputs or situations. Retest your code to ensure that the infinite loop is fixed and that your program now behaves correctly. Code examples in different languages. Here are a few examples in common programming languages demonstrating infinite loops and how to avoid them. Python. Asterisk JavaScript asterisk. Asterisk Java asterisk. Asterisk C++ asterisk. Asterisk C asterisk. Key takeaways. Asterisk infinite loops are a common problem in programming. Asterisk they can cause your program to become unresponsive and consume excessive resources. Asterisk careful coding practices, thorough testing, and the use of debugging tools can help you avoid and identify infinite loops. Asterisk when you encounter an infinite loop, interrupt the program, analyze the code, and fix the error. Asterisk always double check your loop conditions and ensure that there is a clear path towards termination. By understanding the causes of infinite loops and practicing these preventive and debugging techniques, you can significantly reduce the likelihood of getting trapped in one. Good luck, and happy, and infinite loop-free, coding.